Differences in exposure level to endocrine disruptor can be explained by various factors. First, in terms of regulation, we know that the regulation is different across country, with the example of bisphenol A that was restricted before the other country, and so we observe a lower exposure level in French people than other European. Secondly, we also have different habits, so this can explain differences according to ages and sex, depending on the use of cosmetics or diet. And similarly, we can observe differences with age, again, because diet change over ages. Also because some contaminants bioaccumulate in the body, so if we measure exposure to DDE, for example, in blood, the level will be higher in older people than in young children.
So why do we need to develop AOP, which is Adverse Outcome Pathway in toxicology? So AOP in toxicology are very essential. So first, they can be used to have a better understanding of the biological mechanism after an exposure to a chemical. So for example, it can be an endocrine disruptor. Or it can be used for predictive toxicology. So for example, when you develop predictive models, it can be helpful to have an understanding about if an endocrine disruptor is toxic or not. Or you can use it as well to reduce the animal testing, because you can create some computational modeling, for example. So to create an AOP, we need a very high scientific expertise that will be complementary, because an AOP is a conceptual framework that integrates existing knowledge. So for example, we can integrate knowledge from different databases, from laboratory works, or from scientific literature. So for example, we can use tools that exist, so it can be tools based on artificial intelligence, such as the AOP Finder tools. And this tool will allow to screen automatically literature that exists and extract relevant knowledge to build an AOP. So we have different examples of AOPs that have been developed in Oberon. So these AOPs were developed by integration of results from the different partners. So in Oberon we have 11 partners. And these partners have developed targeted experimental and computational test methods. And these results were integrated to build AOPs. So for example, we have AOPs with a phthalate DEHP. So that's a compound that is used in plastic that you can find, for example, in food packaging. And these chemicals has been shown to initiate some increased lipid accumulation that can be connected to increased body mass index in population. Another example is with forever chemical PFOA, which will initiate some molecular disturbance that may be connected to obesity in the population.